I'm interviewing. See, our house is getting worked on. Whoa, crazy. Anyways, climate change,
More about it.
known as global warming. Is it real? Let's start with that.
Yeah, of course it's real. It's 100% real. Everybody's like, well, the Earth heats and cools on a natural cycle over its lifespan. Yeah, that's true and all, and that's great, and that's wonderful. But the thing is that number one, we should be cooling. Number two, for some reason, it's accelerating. Okay, the only debate at this point is whether or not people are doing it. Okay? And I'm just gonna take a wild shot in the dark here and guess that people are doing it because number one, people always argue, well, volcanoes emit more CO2 into the atmosphere annually.
Wait. You gotta first explain how.
Okay.
How does it work? How does global warming work?
Basically.
Let's start with the sun.
CO2 is in the
and
atmosphere.
Einstein's backing you up.
Get out of here. Get out of here, man. Get out of here. CO2 is in the atmosphere, and basically what happens is as the visible light comes through the atmosphere, hits the ground absorbs that energy, the electrons go up a few orbitals. You know what, I'm not going to get down that low because I think a lot of people are going to get lost here. Point is that some of that visible light is converted into infrared light, heat, energy, which is shot up, and then the CO2 grabs it and then re-emits it. And that keeps the Earth warmer longer, which is a good thing in a lot of instances, because, without it, the Earth would kind of be a giant snowball.
So we'd be dead without
we
CO2.
would be dead. You know what? We wouldn't have
maybe
without CO2, we wouldn't have even been alive in the first place.
So then maybe CO2 is good. Why not just
CO2
put more
is
in
great
there?
and all, but human body and life and crap is kind of very, very sensitive to different changes. So, too hot isn't a good thing either. Too cold and too hot is not good. We're kind of at like a sweet spot, but you keep janking with the atmosphere, man, it's not going to go down well.
So we kind of like it. I'll kind of jump in a little bit. So our temperature is 97. That's normal. But at 100...
Human body is 96.8 degrees there.
Okay, 96. I was rounding it up. 97. And let's say it jumps up to 100 degrees. Now we're sick. That's only 3 degrees. So the same thing with the planet Earth.
Kind of.
So...
The problem is, so I just that's a big deal. It only takes... I think the Earth has an average...
So anyways, so what happens with the CO2? CO2 is emitted by
Let me just
plants.
address this. I just want to make this very clear that the average global temperature, because everybody talks about how, sometimes it gets cold and there's snow and stuff, and that means that there's no global warming. No, that's not true at all. When we talk about global warming, we're talking about the average global temperature going up. And I'm saying average, because weather and climate are very different, and I want to establish that right now in this video, that weather and climate are very different. And I'm just going to use Neil deGrasse Tyson's example. If I take Einstein here on a walk, Einstein's going to go left and he's going to go right and he's going to look all around and he's going to look at a bunch of different things while I have him on the leash. That's weather. Me holding the leash, I'm climate. I control the weather. Because climate is an overall average weather. An overall average weather pattern. Weather changes daily because of things like chaos theory and the butterfly effect. But in the end, climate is that trend. So I just want to establish that. They're very different things. Just because it's snowing one day does not mean that the climate is not changing. That doesn't mean the climate is getting colder. That just means that one day, one portion of the weather.
Okay, but let's go to the big one. The Arctic is expanding. The ice in the Arctic.
I just want to, for any sort of any sort of climate change deniers in this watching this video, I'm just actually going to tell you, you can use that all you want because it actually supports the idea that man-made climate change is a thing. Because see, the thing is that the glaciers are actually made of, fresh water. So when you have salt water, essentially what it does is when you put salt into water, it makes water freeze at lower temperatures. Which means that it takes a lot colder, it takes the water getting a lot colder for it to freeze. But when you have the glaciers melting, they're mixing in fresh water, decreasing the amount of salinity, and that means that the water now freezes at a higher temperature. So more icebergs, for the meantime, Meantime, I stress.
And that's only in the Arctic, though.
Yeah, and because
The rest of the planet, the ice is receding.
So the thing is you've got like these melting. It's mixing in the fresh water. That's decreasing the salinity, the amount of salt in the water, and then that's making it freeze more. But as the temperature continues to increase, these are gonna melt now. So right now, that's actually supporting that climate change is a thing.
But we humans only put out, what, 30 million
32 million megatons annually. And I just want to address that, yes, the environment puts out 720 million megatons annually. I believe that. That's roughly right. It might be billion. I don't know. I haven't looked up the statistic in a while, but it's probably right in that area. Alright, he's excited. Everybody always kind of argues that volcanoes put out more CO2 than we could in a million years. That's wrong. That's wrong. Most of the CO2 comes from, different varying life forms, things like that. Right?
Guys, stop.
So the thing is that we put out 32 million megatons. I think 32 million. It might be 32 billion. And the atmosphere or the environment might put out 720 billion. But the environment can only reabsorb that 720 million. So it's like a graph, and essentially we've got this huge stack
So
of CO2.
the thing is, like, in 10 years...
We're adding
right.
on. We're
so
adding
the
on
extra
very
32 million megatons
Just
stays
cannot
in the
be
atmosphere.
reabsorbed.
Right, it's not
It's just-
absorbed.
Right.
So then in 2 years, then we're at 64, and then so on. So you can just do times 10, times 20.
Yeah.
And then, we're already at 600, and, in 20 years, we're already at 640 megatons
Yeah.
in the atmosphere, extra above and beyond, which is not good. And we're just headed in that direction. Anyways, I don't want to make the video too long.
But so then, let's address why CO2 isn't great, because, it's dumb. It's dumb. This is a dumb thing. This shouldn't even be a debate anymore. We've proven it. It's practically proven.
So what about this 97% of scientists are paid off by the government?
Okay, yeah,
by the way, worldwide. So somebody
just dumb.
reached in their pocket and paid, and so all scientists are ushered into the room and said, "Look, we need you to tell the truth, but when it comes to this particular thing, we need you to just lie. We need you to lie and just make up and say it's man-made."
Dumb. I'm just gonna say it's a lot easier to pay off 3%
I agree.
than 97%. So let's cut that argument. It's real dumb. It's real dumb. This shouldn't be a debate anymore. So buy an electric car if you can afford it. I really urge you to.
Hey.
Because they're gas efficient. They're very gas efficient. Everybody argues that they put out everybody argues that because a lot of our electricity comes from things that create CO2, that they're not efficient, but they actually are.
Yeah.
Because with the increasing efficiency of with the batteries in electric cars, if you're going to drive an electric car for a week, it's not going to be any different from driving a gas-powered car. But if you're going to drive it for 2 years, you're actually really benefiting the environment.
All right.
So buy an electric car from Tesla or get a smart car. You're actually helping the environment.
All right. Sounds good. All right, there it is.
Yeah.
Science in a nutshell.